Chapter 7, Lesson 3, what is it on? Similarity and transformations. We're going to skip the top part because we can. And we're just going to look at these three words: dilation, scale factor, and similar figures. What is, I want you guys to rate yourself on how familiar you are with these. I'm the teacher, so I'm going to mark these. If you're not the teacher and you're not familiar with them, don't mark the ones that I marked. What would you say a good definition is for a dilation? Raise your hand if you were pretty familiar, if you knew it well, if you knew dilations well. So a dilation is when a figure is enlarged or reduced.
In size?
Yep, in size.
Like when you get your eyes dilated.
Yeah, when your eyes get dilated, that means they dilate your pupils and make them bigger. And it's really hard to see. A scale factor is the ratio of sides. So it's the number that you multiply by. And then the last one, similar figures, are figures that are the same shape and then maybe same shape, may be different sizes. So they gave this example right here, this picture. This is called a fractal. What is it called? A fractal. And in fact, the cool thing is fractals are found all over in nature. I have this really clever vegetable. There is a vegetable called a fractally.
What? Is it yummy?
It's related to the broccoli family. So it depends on how you feel about broccoli.
I like broccoli.
I love broccoli myself. So to me, this looks like it's imagination. Like it's an imaginary thing. Would you guys agree that looks like an imaginary thing? But it really is. Like, do you see like there's leaves? I've seen one. I took a picture of one, but it would take too long for me to find mine. So these are, what a fractal is they take, like, there's one shape. Do you see like there's a tiny little like tree looking thing right there?
Yeah.
And all of those are on one little tree, and all of those are on one big thing, and then it keeps on going. So another example of a fractal, have you guys ever seen a fern?
Yes.
A fern, like the plant, a fern? Let me see if I can do it.
Isn't it like a pine tree? Kind of. Not really.
Not at all. So, this is just a drawing of a fern. This is a picture of the leaves. So, if it can zoom in, see how like there's a little, like each one of these little tiny things is a little version of what this big one is, which is a little version of what this big one is. So those are called fractals. So, no. That's a different kind. That's a Venus flytrap. So, so that's what happens here. Like these are all like a little circle thing, and then that comes off of another circle thing, which comes off of another circle thing, and then there's like all these repeated patterns. So that's when it happens. That's when similarity happens in nature. So what you are supposed to do with this homework is you are supposed to determine if the sides are proportional. Underneath this picture, will you please put the word proportional? Proportional. And if you ever find a side that does not have the same ratio, then it's not proportional and it's not similar. So look at what they did here. They found that all of the ratios were 2 to 1. And they're like, oh, that was easy. We're done.
That's all we do?
That's all you do. Like go through the ratios and see if the sides are proportional. With this, they rotated it like this, and then they tried it out. So they said, looks like this one goes with this one, so that was 3 to 4. But then with the longer sides, it went 5 to 7. See how these two are different? 3 to 4 and 5 to 7? Not proportional, not similar. Does that make sense? Pretty easy like that. So that's all you're doing on these. We're going to see if they're proportional And if they are, great. If not, stop. So this is how I start it. I try PQ. Which side on the small triangle goes with PQ? ST. And then, so how long is PQ? 6. How long is ST? 3. Good. And then we have, let's do QR. How long is QR? What one does QR go with?
UT.
With TU. And then QR is how long? Let's see. 2, 4, 6, 8, 10. Good. And then TU is 5. And so far, everything is proportional, right? They're looking pretty good. Because what does 6/3 reduce to? 2 over 1. And this reduces to 2 over 1. Now, here's where it gets tricky. So the next sides are SU. Oh, I meant to put that on the bottom. SU. SU goes with what one on this one? PR was supposed to go on top. Okay, so PR. This is where you have to, because PR is the hypotenuse, right? So we're going to write up here at the top, put hypotenuse. To find the hypotenuse, you're going to do the square root of the leg squared plus the leg squared. So that's what we want to do, but now we're going to find the specifics. So PR is going to be the square root. And what are the legs of this triangle? 6 and 10. So 6 squared plus 10 squared. Which is over, and then what are the legs of the small triangle?
4 and 3. Or 6.
3 and 5, the bottom one. So 3 squared plus 5 squared. And the cool thing is you can make your calculator do most of it. So you can get a calculator. It'd be awesome if you can do this without a calculator. What is 6 squared? 36. What is 10 squared? 100. So this is really, so I'm just going to do this up here. This is really 136. What is 3 squared?
6.
No. 9. And 5 squared? 25. So 9 plus 25 is? 34. So then I'm going to do this in my calculator. I'm going to do, I'm going to turn it on because it works better when it turns on. Okay, square root, weird, right? 130, square root of 136 divided by the square root of 34. And it's also 2. So it is proportional. So then we're going, and my favorite, let's look at the directions. Do these problems to find out. I think they forgot to write it. So then we're going to put similar. And then we're going to put ratio, similar, period. The ratio is 2 to 1. Okay, let's do that for this next one. Do you want to try it on your own? Be on your own?
I already know the answer.
You already know the answer. Is it similar? No, you got no. Which ones did you have that were no?
A and B and
So let's see. AB goes with EF. And right now, how long is AB?
3.
How long is EF? 2. Okay, that's okay. Now let's do another easy side. So let's do AD. How long is AD?
5.
5. How long, and then what does that go with?
4.
So that's EH, and that's 4. Are those the same ratio?
No.
The cool thing is once you see that they're not the same ratio, you can stop and say not similar. Cool, huh? It kind of looks like it's the same shape, but you can kind of also see that this one's wider and that one's narrower. Okay, so with the scale factor, if that scale factor is between 0 and 1, it shrinks it. If it's bigger than 1, it makes it grow. So let me show you an example of that, of something that you use in everyday life. So if I were to take the picture of this fern, and I did this to it, that would be like my K, my scale factor, is see how I'm keeping one finger in the same spot? It really has a hard time with it still though. So zooming in, that would be like the scale factor is bigger than 1. And then if I went like this and made it smaller, that would be the scale factor smaller than 1 and greater than 0. Or if I just tapped on it, like didn't do anything to it, that would be the scale factor is 1. So smaller than 1 is 1, bigger than 1, right? Good? Okay. So there's this picture of the dog. Ken, he does 2 things to it. So first, he wants to put it on his website. So he dilates it by a scale factor of 2. And then he's like, dang, he's like, so cute. I'm going to make a print of it. So then he multiplies that new size by 1.5, and we want to know the final thing. So the original photo was 2 inches by 3 inches, and here he was timesing it by 2. So he got these new things. Took them down here, and then times them by the 1.5. So the new thing, the print that he was going to hang on his wall because that dog is so dang cute, then he decided to do 6 by 9. Yeah? Make sense? Yeah. You're going to do the same thing on the next problem, and then that's it for the homework, the lesson. So an art show offers different size prints for the same printing. The original one was 24 by 30. So then one printer enlarges it by 1.5, and another one multiplies it by 3. So we're going to do that same thing. So we're going to take our original ones, and I'm going to do this in pen so you can see it better. So you're going to take your 24, and what's the first one we're supposed to times it by? 1.5. So times by 1.5, and what do we get? 36. And then we're supposed to take that 36 and multiply it by the next one, which was? 3. Final answer? 108. 108. Nice. Okay, let's do that with the next one. So it's 24 by 30. First times it by what? 1.5 and get? 45. Nice work. And then we do 45 times it by what again? 3. And we got? 135. So that means the new, what are the dimensions of the largest print? So the largest would be 108 centimeters by 135 centimeters. And then are both of the enlarged prints similar to the original? So I'm going to say yes, comma, similar. All right. Your homework is 4 problems in ALEKS for 7.3, or in the book, if you choose to do it in the book, which is fine, it is 1 through 6, 8 through 10, and 15 through 20.